Let's solve today's problem. The first, we need to understand the problem first. So in the problem, we will have the tokens and the power to do the things with the token, and we have the face up and the face down action. So just remember that when we face up, we power up. Our power is will be I mean that we face when we face up, we gain one score and losing the power that equal to the token. Yeah. So in this case, we cannot face up because the power is less than the token value. So the output is 0 because we gain no score. Yeah. In the example 2, we can face up the second token, gain one score, and reduce the power to the power is now reduced from the 150, we minus the token value, and then we will have the power remaining is 50, and the score become 1. Yeah. And at this time we just have 200 remaining token left, and we cannot power up anymore because we do not have enough power. And for the last example, we have power 200. So in this case, we can power face up the first token, the second token, and cannot do anything with the remaining. And after we face up the first token, we can our power become 100 and the score 1. But if we face up the second token, the story 1 2. But if we after we face up the first token, we face down the last token, we will have the power that is 200 minus 100 and plus 400, and we have 5. Yeah. So at that time we will have 500. Yeah. When we face up the first token, we get the score 1, and when we face down the last token, we have power up, but we have the score minus 1, and the score become 0. But now we have 500 token, and we already done with the first token and the last token, and we have remaining 2 token, 200 and 300, and it's equal to the power now. So we can face up 2 remaining token, and the score become 0 to become 2, and the power become 0. And now we already done with all 4 tokens, so the output is the score is 2. Okay, so now let's now think about how to solve this problem. This problem we can use the backtracking and just get one token and decide to face up or face down it, and then loop and explore other token, and to generate all the possible solution. But this will be lead to time limit exception, because the sample is 1000, so the time will be the time complexity will be 2 power 1000, which is very large. So it will be TLE, time limit exception. so we need to find another way. So for another way, we have this. We can consider that we can open any token, and we face up and face down. We will interact with any token in the array, and we also know that when we face up token to gain the score and lose the power, we prefer to do it with the least value token, and when we face down to gain the power and lose the score, we prefer the highest value token so that we can gain the max power. Yeah, so we can think about it, and we can use the two pointer method for this, and before that we can sort the array from the low to the high, so that we can use two pointer, and from the left pointer we will use it to face up and lose power and gain score, and for the last the right pointer we will face down and gain the power and lose the score. Yeah, okay, so let's start the code. We will sort the token arrays, and then we will have two pointer, the left and the right. With the left will be 0 and the right will be the length of the token -1, and we can use the two pointer technique to do it. So while left not is it not more than the right, we can check the first we check the power. So if power is more than the token, if we have more power than the token, we can face up it to gain the score. Okay, so face up the token by the first we lose the power, and we gain the score. Okay, we get just the init, the default score, and then we move the left to one step. Okay, if we don't have enough power anymore, we try to face down the last token. Let's see that let's assume that this token is already sorted, so we face up the first and the two this left token, but when the power is not enough, we can button the score. We already have the score now, so we can try to face down the score from the last. Okay, so if score is more than 0, we can face down to gain the right token value, and the score will be -1, and then we can move the right to one step, and if when we do all the stuff and nothing left, we can return the score. By any chance, if we can flip up, face up on the token without the need to face down, we can, the left will be more than the right, and in this case we out the loop, so we turn the score 2. Yeah, and you can submit it. sort. Okay. Okay. Yeah, as you can see, it passed the first one, but in this case, why it's not work? We can say that the output is 0. It means that if it means that when we get the score here, and we loop again, and if the score more than 0, we consume the score, so eventually the score will be 0. So we need to have another check in this. We check if the left is less than the right, mean that, and the left is we just face down the token if we check that the left is less than the right. If the left is equal to the right, it means that and it means that when the condition go here, we not have enough power anymore, so we can stop the loop now instead of try to flip to face down the right and then -1 right here, and we will lose the score for no thing. Yeah. Okay, let's try again. Okay, that we pass this with the output here, and we can check the power here. We still have the output here. Okay, so let's see. We sort the yeah, we need have the equal here, because now if the power equal to the token, we can still face up it. Yeah, we passed it. Let's try to submit it. Okay, our solution is quite efficient, and it will take O and complexity, because we loop we have a loop with 2 pointer here, and that but we also have the sort here, so normally the sort will take O and log n. Yeah, so the final complexity will be O and log n, and for the time every sort we can assume that the space complexity is also the ON. Yeah, and in our solution we don't use any linear space, so it's just O1 space complexity, so overall it will be ON space complexity. Yeah. Okay, so that's all. Thank you for watching. See you on the next problem.